Student ID is 24335285285. In front of you, you can see three models in a CubeMap environment. This environment is basically a sea with mountains. And I have three objects. One is teapot, other is torus shaped, and third one is sphere. Currently, you can see there are three modes three transmission modes and material properties, which is reflection, refraction, Fresnel, and chromatic dispersion. So firstly, you can see the reflection on each of the object. It yeah. So it can you can see it reflects like a proper mirror. You can see the mountains that are behind in the scene, and you can see in all three of them. Then we move to refraction. Here you can see that they are transparent completely, because currently the refractivity ratio is 1, so they act like air, right? All three of them. So as I decrease the refractivity, you can see the image is getting inverted like a normal refraction happens. At 0.4, it is diamond like. The material is diamond like, 0.14 approximately the ratio. And as I decrease it, you can see the refraction. You can see the reflection very evidently, very properly. You can see the inverted image here, and this mountain is basically this one here, and you can see the ocean that should be down there. And yeah, so inverted image due to refraction in all three of them together in different geometry styles. In torus, you can see this, in teapot also. And as I increase the refractivity ratio, you can see the refraction is least when the ratio is 1, because I've decreased the material index to 1 from about 2.5 to 3. And we have the preset, which is like, yeah, it converts the refractivity to 1. Next would be Fresnel. Fresnel is basically a mix of refraction and reflection based on the Fresnel-Schilk equation. In that equation, we have something called the base reflectivity, which is also called the F0, F0. Base reflectivity uh, is the parameter that actually controls how much reflection versus refraction should happen in Fresnel. Right? Yeah. So so for example, I increase the refractivity to 1, right? So it is completely transparent, but there is a bit of reflection there. So if I increase the reflectivity, you can still see the reflection, although it is air-like, but you can see the reflection. So this acts like a bubble here, right? For all the three objects, you can see that. It acts like a bubble. And as I increase the reflectivity, this becomes more sharper, the reflection, and this becomes complete reflection. Now to see a good Fresnel effect, what I can do is decrease the reflectivity ratio to about 0.5 and keep the base reflectivity there. So now you can see refraction down here of the mountains behind the teapot, like in front of us and behind the teapot, and you can see the reflection behind us, the mountains that are behind us, and you can see this all of them. So if I decrease the refractive index a lot, you can see more that refraction is dominating now more than reflection. Right? The ratio can't be 0, so it will be about 0.1. And as I increase it, the refraction is gone, and there is complete transparency if I decrease the reflection also. So around here, it is a very good spot. Diamond like refractive index, and then reflectivity is also in the middle, the base reflectivity. It gives a good Fresnel effect. Yeah. So as I increase the reflectivity, you can see there is refraction plus reflectance, both. Right. So this is a glass like preset. It looks like glass. And finally, we have chromatic dispersion. In chromatic dispersion, it divides each channel has a different refractive index, so that the channels disperse in a different way and we can see each channel differently. So for example, I have a preset rainbow here. we can see the refractive index for red channel is the highest, then comes green, then comes blue. And then base refractor is 0.04, so it's quite less. You can see the different colors here. The colors are basically the white colors divided into the three colors RGB. Yeah, right. So that's it. That is for my assignment 2 transmissions. Thank you.